Hi everyone and welcome back to the channel. So it's been a while. The weather hasn't been the greatest here in Cyprus, so I hope it's a lot better where you are. So I thought I'd take the opportunity while we've got this extensive days and days of broken cloud to actually start getting into a project I've been wanting to do for a while, and that's building an AllSky camera. So how long is a while? Well, the domes you can see here in front of me, these are 6-inch plexiglass domes. I actually bought these back in December 2021 with a view to doing this project and just never got around to it. Then I was watching Luca Matico's channel and he did a review of the new ASI676 camera, and I thought, well, that looks like an ideal camera for building an AllSky camera. So I bought one. And that's what we're going to hopefully get around to actually completing, is this project. So check out Luke's channel and you can get a full review there. But the reason I decided to go with this camera is because of its square sensor. So it's a 7.1mm sensor, and it is 3,552mm square, and that'll make an ideal AllSky view. And it does come with the little focusing dome to give you that fisheye view. So hopefully this will turn out all good. And then to power it, I recently replaced my Home Assistant Raspberry Pi server. So it was a Raspberry Pi 4 and I upgraded it to a Raspberry Pi 5, and that did make a huge difference in terms of responsiveness through the web interface. But the Home Assistant I predominantly use for controlling the observatory, all the power systems, etc. So it did make a big difference there in terms of responsiveness, as I say, as well as all the trending of the data and just generally monitoring all the various electronics that are on that setup. So that obviously left me with this leftover Raspberry Pi 4. And I've also got a 1TB SSD that the OS runs on, and all the data is stored on, so it's sitting spare. So I thought, well, rather than go and buy something new, I'll just try this one first and see how it performs, and I can always change it in the future. And for the operating system will obviously be the Raspberry Pi, but the control software for the AllSky and the application, I'm going to take this AllSky GitHub repository for a spin and see if we can get this up and running and doing what we want it to do. So it should all be relatively straightforward, we hope. But let's just get into it and see how we go. Alright, so in the camera box, we have got a nice heavy duty USB 3 Type A to Type B cable. We've got the actual camera itself with its fisheye, and it also has obviously the USB 3 port, Type B. It has an ST4 guiding port, not that we'll be using it. And on the bottom we've got your standard 1/4 inch connection, and a little focus knob here for adjusting the focus on the camera. The camera also does come with an eyepiece, so I could in theory also use this camera onto the telescopes for doing planetary work. Comes with an ST4 cable, a lens cap, and obviously a little instruction book. So we won't be needing some of those, and let's see how we go on. Alright, so here is the Raspberry Pi powered up, and it's connected through this HDMI cable to the monitor. You can see up in the top here it's got Home Assistant. Sorry, I don't have a capture card, so I can't get close up on it, but you don't need to see that anyway. It just says Home Assistant, so we know the Raspberry Pi is working, we know the SD is working, and we know the network's working. So next I'm going to use my micro SD card adapter and a micro SD card to install the operating system. And to do that, I hopped over to the Home Assistant, into Raspberry Pi's website and grabbed the Raspberry Pi imager. So now we can install the SD card into the computer. And we can choose what we're installing. So we're on a Raspberry Pi 4, and it says in the AllSky GitHub repository that it has to be your standard Raspberry Pi operating system, so we can't use any of the other ones that you can see in the list here. So we stick to the original, and we've got the bookworm version with Raspberry Pi desktop. So we'll select that, and it's going to go onto this mass storage device. This is the micro SD card, and we'll just click next. Edit settings, so it's going to set up the Raspberry Pi as the host name Raspberry Pi, the root password and everything. It's connected to the Wi-Fi network, and time zone SSH is enabled, and we'll probably need it, and just the default settings there. So we can save that, and we can just apply that and let it do its thing. Alright, so there's the SD card that we've prepared. Now hopefully we don't need to use this, it's merely a backup, because in theory I should be able to just pull out the SSD that's on the connected to the Raspberry Pi, repower it, and hopefully it'll boot into the Net Installer setup of the Raspberry Pi, which we can then directly off the network install the Raspberry Pi operating system back onto the SSD once I plug it back in again once we get to that stage. So that's what we're going to give it a try. So I'm going to power down the Raspberry Pi, unplug the SSD, and reboot the Raspberry Pi with no SSD installed and no micro SD card installed. And hopefully we'll see that come up on the screen. And there we go. So it says press and hold shift to stop boot and start net install. So let's press shift and hold. And it says it's waiting for the network. It's setting up a network connection. And it's downloading the installer. So we'll leave that to do its thing and come back in a second. Alright, so it has downloaded the installer, rebooted the Pi, and now if I plug the SSD back in, we should be able to choose Raspberry Pi 4, choose the operating system. So again, we'll use the Debian Bookworm, the recommended one, and we should hopefully get the SSD now that I've plugged it back in, and there it is, 1 terabyte. And we will click next. Let's edit the settings. It tells me all existing data on the SSD will be clear. Do you want to continue? Yep. And leave it to do its thing. Alright, so it finished installing the OS onto the SSD, and it's rebooted the Pi. It's obviously going through its installation setup itself. And there we have the Raspberry Pi desktop. Get a terminal, all working great. And we've got a browser, a file manager. Perfect. Alright, so what I'm going to do now is I'm going to run the updates on the Raspberry Pi. There's a button in the top right of the desktop. You can't really see it on the screen there. And then I'm going to follow the installation guide from the AllSky GitHub and see how that ends up. So I'll catch you in a bit. Alright, so it's been a little over a week. I had things to do and I did run into trouble, as you could see. So on the screen you can see that we ran into a no camera found, and I had a feeling this might have something to do with the camera being relatively new. So the AllSky Camera software hasn't been updated to include the new ZWO library. So I went on and followed the troubleshooting guide and just confirmed that the 676 camera isn't on the currently supported camera list in the library, and sure enough it wasn't there. So I went back onto the GitHub issues tracker and did a search in there, and it's already been reported by a couple of people that the camera isn't supported, and the feedback from the developer is that it'll be included in the next release of the AllSky software, which is anticipated to be in the next few weeks or so. So I've got two options. I can either wait or I can follow one of the other instructions, which is to manually copy some of the files from the development build across onto the Raspberry Pi, and then rebuild the library, the ZWO library, and that should initiate the detection of the camera within the current AllSky software. So that is what I'm going to try and do next. Alright, so here we are on the GitHub issues tracker, and you can see how to update SDK to newest version to support new cameras. And basically what we're going to do is we're going to go into the source folder and library for the various directories. So for example, RMV7 here, and it's basically renaming the ASI library file to old, download the new copy off of the GitHub repository, and then rebuild the capture program within the library. So if we hop across to the source folder, here we can see in AllSky source lib, here's all the various libraries, and they all contain this lib ASI camera camera 2.8 file. So I'm going to go into the equivalent folder on the Raspberry Pi, which we probably can't read on the screen there from the capture, but in the folder tree, AllSky, in the library, and you can see there's all the various directories that match the structure on the GitHub repository. And I'm just going to replace out all these lib camera 2.a files and then rebuild the capture program, hopefully. And if it doesn't work, then I'll just have to wait a few weeks until the new release of AllSky comes out, but I'm sure we can crack this. Well, that didn't work. Okay, so it still doesn't find a camera, so something's not quite right yet. Let me investigate. Alright, so what I think I did wrong was I hadn't changed the branch. So if you look at the top left of the file tree, you can see you can choose which software branch we're pulling the files from. So I was effectively pulling them from the current build, which matched the files that were already installed on the Raspberry Pi. So I changed the branch to the 2000 V2024 build and copied the files across this time. So hopefully now if I do make capture, it still says nothing to do, and yet no camera detected. Alright, so back to the drawing board. Alright, so this time I am going to try and just copy the whole branch from that development branch, so that's the v2004.xx.xx branch, and put it into the Raspberry Pi directly. So I have moved the existing AllSky installation into another directory, and now we're going to try and pull in using Git that branch. So we're pulling down the build this time. So we'll leave it to do its thing, and I'll be back in a minute. Alright, so Git's completed cloning that branch, or it appears to have, and I've just done a directory listing there, and I can see the AllSky folder is still there, and they backed up the old installation, the AllSky-saved, and I can see in the AllSky folder now we do have an install file. So let's run it and see what happens. Alright, so it says here clearly it's a tester's release. So we're just going to continue with the installation. I can always wipe this once the official release comes if there is any issues, but at least it gets me up and going and playing with it and seeing how it works. So let's go. Alright, so the camera is connected. Let's see if it detects it this time. Alright, so it says no prior version of AllSky has been found, which is good. If you do have a prior version, you want images, darks, and certain settings moved, blah, 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 rename the prior version. So we haven't done that, so we just want to continue. I'll just choose the default locale. So it's found the camera now. So we've got progress. So let's continue the installation. Alright, so we've got through the installer, and now it's asking for my location, so I'll just let it use the defaults at the moment. I can always change them later, I would imagine, in the settings. And there we can see, so it will now reboot the Raspberry Pi, and then I can either use the IP address or iSkull.local to get into it. So I will reboot the Pi and let it do its thing, and I'll come back in a minute. Alright, so we're back, and the Raspberry Pi rebooted, and once it looked like it was rebooted, I opened up a browser on my normal PC, and I went to the address that's been assigned in my router to the AllSky Camera, and it's taken me to this web interface, and that's after it prompted me for a username and password. So I entered the default as described in the documentation, and it takes me to this page. So it says use the WebUI AllSky settings link to configure AllSky. So AllSky settings, and here are all the settings. So capture, save, auto exposure. So there's a lot of settings I can obviously play with. So I will need to have a look through these in some detail. But let's, for the time being, just click Save Changes. We'll clear that system message. And AllSky is starting. This is clicking on the live view page. And there we have it. We have got an out of focus image. So I'm going to have a tweak of the zoom, or the focus I should say, on the camera, and see if I can get a better image. Alright, so what I have done to try and speed up the setting of the focus is I've disconnected the ZWO camera from the Raspberry Pi, and I've plugged it into my main PC, and I've got ASI Studio installed and the camera driver installed on my main Windows PC. So now you can see on the AllSky web interface that the camera cannot be found. It actually came up scanning the bus, but it came up with this finally with this message. And here you can see in the ASI capture software, I have got the AllSky camera running a real-time view. And as you can see, there you lot are, and there's me. And this makes it a lot easier to adjust the focus because you've got a real-time view all the time. That's been going through focus. So once we get it out into the field, I'll be able to put this, connect it up to the PC in the observatory, or at least get it as close as I can to focus now, and I would imagine it won't be far off once we get outside. And what I could even do potentially is, while I'm in the house and I've got access to the PC, I could stick the camera outside the window and just make sure that the long distance view is in focus. But I would imagine it's pretty good. So there's my office through. There's the sim rig. Blinds are closed because I was getting too much glare off the TV. 3D printers, shelves, and the main computer, and me. Hi. Alright, so all good. So what I'm going to do now is I'm going to lock this focus down once I'm sure that that's sharp. So I'm going to zoom in on my edge of my head and just get this as sharp as possible, which is round about there, not in any very elegant view. And I'm going to lock the camera. Excellent. Alright, so I can put this back into the Raspberry Pi and see if it picks up again. Alright, so there we are, back on the Raspberry Pi, plugged the camera straight into it and it picked up the camera no problem. And I'd actually changed the settings to every, whatever it was, 100 milliseconds or something to try and speed it up, but it's still not fast enough to do the focusing. That's why I took it out. So I can clear that message that says the camera wasn't detected. And there is the current view. Alright, so what I can do now is I can go and play around with the settings, and then I am going to go and see how I'm going to install it in the observatory. So we will catch you at some point. One enclosure, totally excessive, but it was the only junction box that I could get off the shelf without raking around Cyprus trying to find something. So it's a bit excessive, but it was cheap. It'll do. And I've mounted the Perspex dome on top of it, cut a hole in the middle with a hole saw, and I've siliconed and bolted down the Perspex dome onto the top of the junction box. And as you can see on the screen, I modelled up these simple components and 3D printed one. So the red one is actually the spacer to take from the bottom of the junction box to get the camera at the right height. And then the grey one, that is a hub that I've got for mounting the box on top of a pole. So the antenna for the wireless bridge that comes back to the house has got nothing on top of it, so I made this little boss that I can put on top of the post and then clamp it on place, and that'll also give me the rotation for getting north in the right direction on the camera. And the red piece, the height adjuster, I just printed that with PLA CF filament. And then the boss for going on top of the pipe, it's a bit more heavy duty and it's in the elements, so that's been printed in PETG. So that'll do for the time being, and if it doesn't work I can always go and find the right box to get this mounted on in some different brackets. But it's all I had available at hand in the nearby shops, so I didn't want to go spending hours raking around trying to find an electrical shop that had a suitable 8-inch square by thin junction box. So it'll do, and if not, as I say, I can always go and order it. So what I've also done is I put in a gland in there, so I had to be big enough to allow me to get the USB 3 type B cable through. So I'm only going to run a cable to the camera. The Raspberry Pi I'm going to have inside the observatory next to the network switch, and it'll be powered from the internals of the observatory. And then I'll just have the USB cable going out to the camera, and that's it. So the other way I've done this means that if I've got to go in and adjust focus and things, I can always just undo the 4 screws and lift the lid straight off, giving me direct access to the camera. And I can also get some slight rotation on there by just loosening off the 1/4-inch bolt underneath there on the mount. And then, as I say, I've got access to the camera focuser on the top, no problem. So then I can obviously, once I've adjusted focus, I can just pop the lid back on, and I know I haven't disturbed rotation or anything like that on the camera. Alright, so what I'm going to do now is I'm going to go and take this out to the observatory. I'm going to get it mounted on the post, get the cables in and get it all up and running, and we'll probably catch you out there just in a bit. Alright, so here we are outside at the observatory, and you can see I've got the camera mounted. So there's the antenna for the Wi-Fi bridge back to the house, and then I've got up on top of the camera. Now I'm not too worried about the height of the camera relative to the dome. Obviously that's looking west, and it's very, very low in the horizon, so I never image down there anyway, so I don't think it'll be a problem. The only thing I have noticed on the live feed is obviously the proximity to the dome means that I do see a lot of the observatory on the right hand side of the image, so I might look at it in the future and maybe reposition it, but for the time being, to get it up and working and tested, all good. So I've just got it on the boss underneath. I've used my phone to point it to true north, and it's pretty close, so I think that'll do. And then I just tightened up the boss there just to hold everything in place, and then the red cable comes down and just goes through the gland. Now I just still need to weatherproof these, but I'll worry about that later, as there's very little chance of rain here this time of year. And inside the observatory, I've got it temporarily set up connected to the next to the network switch, and I have got wireless connected and Ethernet connected, so I've got the backup there if one of the links goes down. It'll obviously prefer to use the Ethernet connection anyway. So the Raspberry Pi is just sat here, and I might mount it up on the wall. The only thing is it might get a little bit warm, but it should be okay that side of the dome. And then I've got the SSDs just standing up there at the moment, so I might tidy up this all later, and likewise I'll need to weatherproof the connection here, the cable coming in on the left hand side. And then, as you can see on the screen, so this is the observatory secondary monitor that I use when I'm inside the observatory, and AllSky software is running on the Raspberry Pi, no problems, and we can see the clouds. Alright, so here we are back inside the house, and it's been a couple of days now since I installed the AllSky at the observatory. So here we are in the browser, connected into the Raspberry Pi in the observatory, and this is the web interface, the admin interface for the AllSky software. And here we can see the current daytime view from the camera. So it's 2:30 in the afternoon here in Cyprus, and a nice big cloud has rolled in by. We're just not getting any break from the clouds, but never mind. So yep, it's all working. If I click on the images tab, we can see over the last few days it's been collecting images. So if I click on yesterday, for example, we can see a whole bunch of thumbnails from the images. Now, I don't know what's going on with the unit. I get occasionally these batches of it's unable to create thumbnails, so there's maybe still some tweaks I need to do to the software, or it's maybe just because I'm not using the official release that there's something maybe else going on. But nevertheless, it is picking up images, and I can click on the images. So here's one from 9 o'clock last night, and we can see the stars there in the images. The other thing I've noticed is this green bars that appear on the image. So I don't know where they're coming from, if it's something to do in the processing or it's a setting somewhere. So again, it's something else I need to try and figure out what's going on. Hopefully they'll disappear though once the official release comes out. But at least the AllSky unit's up and working. I also enabled it to do star trails. There hasn't been many due to obviously the clouds, but there was one from, where was it? The first night. So this was a star trail that it automatically generated. Again, heavy cloud, but you can see the star trails around Polaris there. And if we click on the zoom, you can see exactly how that's come out. So not too bad for a first attempt. And the other thing was the time lapse. So if we look at a time lapse, so this is yesterday's time lapse. We can see all the cloud we've had throughout the day. And rolling into night, and we'll start to see stars and the objects appearing. Alright, so the other thing was the kilograms. So that was another feature I turned on. So the kilograms, obviously the snapshot slice throughout the night. So if we look at last night's kilogram, here it is here, and we can see the timeline across the bottom. Or this is yesterday's kilogram, I should say. Again, probably still some more tweaking to do on settings. The other thing that I enabled was in the modules, so the meteor detection, so nighttime capture, meteor detection. So I still need to look and see how that functions. And I've also added the Discord module. So I'm actually currently building out a Discord server for all my various YouTube channels and what I get up to and things like that. So this will actually push the images directly up to a channel on YouTube, on Discord. So more about Discord at a later date, but it's not public yet. Alright, and then I installed the website software locally on the Raspberry Pi. So again, it's a separate module or a separate package that you can pull in to the Raspberry Pi. So I've got it running locally on there. I'm still looking at options of how to host if I want to publish or push these images up to my website, for example. But that's all something that's a work in progress. But ultimately, it's all working. Everything appears to be doing as it should, despite the problems of trying to get the development build up and running, to get the camera detected, etc. And hopefully the owners of the AllSky system will be able to, or will release an official build, public build in the near future. They did say on their GitHub it's going to be a few weeks, so maybe by the end of this year, hopefully that'll be out and we can get a proper build. I might also look at upgrading that Raspberry Pi. Now that I know it all works and the camera works fine, I'll probably put in a Raspberry Pi 5, similar to what I did for the Home Assistant. It's a bit more powerful, so it'll make it easier processing the images and doing all the detection and things like that. But at least we've got a up and running AllSky camera. Alright, so really that's all I've got for you today. I hope you get some clear skies because I'm not getting any joy there. So I'm not going to get any imaging done before I go back to work next week. But at least I've got one project out of the way and hopefully it'll work and continue to work in the future. So clear skies everyone, thanks for watching and we'll catch you later.